Hello everyone, thanks for joining our webinar. It is called AI-powered personalized shopping plus recommendation engine with OpenAI CLIP. So we have Akmal today who will be our speaker for the event. And you might know him because he's a very regular speaker at our events. And I'm Yukti, I'll be your host and moderator for this event. So if you have any questions, feel free to drop a message to me on LinkedIn. And if there's anything that you want to if there's any feedback or anything else, feel free to reach out to us at team@singlestore.com. Just give me a second, I'll hit live streaming and I think we'll be good to go. So if you like this topic today, um, we have many topics that are going to be streamed in the coming few days and in the next few weeks as well. Akmal, can you please move to the next slide that has information? So, all right. So we have obviously today's topic is AI powered personalized shopping engines. So on December 12th, we have built vector embeddings for video via Python Notebook plus OpenAI. And on December 16th, if that topic is interesting to you, full text search with the Lucene version. So if any of these topics are interesting, feel free to head to the landing pages. You can access them by scanning the QR code that is present on your screen. And I hope to see you all there as well. So today's session will be like a hands-on session, and I will be sharing the resources to everything that we have prepared in the chat. And if there's any questions, like you're not able to follow along in real time, so just feel free to use the Q&A button, which is present at the bottom of your console, because the chat is disabled and you're currently in a listen only mode. So yeah, we would like to have an active discussion during the webinar. So if there's anything, like just feel free to reach out to us using that button and we'll take care of your question and query, no matter what it is. So another thing to help you get started, we have a free shared tier version that is completely free of charge, and you don't need to put in any credit cards or like whatever to start. So Akmal is obviously he's going to explain it to you better. So yeah, you can sign up for the free trial and like literally get started with the session in real time. So Akmal, I'm going to hand it over to you, and thanks everyone for joining.
Yeah, great. Well, thank you, Yukti, and thank you all for joining. Before we go further, let me just try something. Something I wanted to do with, okay, there we go. So this is actually better in presenter view because what it does, it gives me the opportunity to keep my, there we go, try again. Bear with me. Start. Presenter view. It doesn't like it. Oh, it doesn't matter. It's okay. We can manage without it. Not a big problem. All right, let's just go to full screen. There we are. It works. So the thing I was looking for, if you're watching, is I need my tabs at the top here. It's a lot easier rather than full screen where it literally takes over the entire screen because it makes it switching from one tab to the other a lot easier. All right. Well, thank you very much for joining. Appreciate your time is valuable, and I know it's kind of that time of year. Depending on where you are in the world. Certainly in the Western world, December tends to get very quiet, and it's leading up to Christmas time. So we appreciate your time and effort in joining today. What I would say is that for the webinars that Yukti mentioned, if you joined us last week, I covered a little bit of clip, essentially a kind of bit of a taster, just show you some basics in terms of getting going with clip. But today we'll do a bit more. So we'll actually try to utilize it for something more substantial than we did last week. And then we'll conclude on Thursday this week with how we could manage video, for example, using clip. Now, I appreciate that there are lots of options today and things are just moving in leaps and bounds. Every day there is some new announcement about some vendor or some open source project that has added more capabilities. And now you can do this, now you can do that. You can work with video and audio and all sorts of things. I mean, awesome. That's really, really cool. And it's great. It's challenging for us as developers keeping on top of all of this. I mean, it's a big task. And as I've mentioned to other people, both professional colleagues and colleagues at SingleStore, it's challenging for us today. I mean, I've never seen it in my entire IT career. I have never seen the pace of change so fast as it is today. And I don't envy you. So, if you're looking for solutions and you're looking for ideas, it's great that there's so much choice, but equally the downside is there's so much choice. I mean, it's a problem. But Clip is nice. I mean, it works well in a number of scenarios, and it's free and it's relatively easy to use. And it's great, especially if you're working with images and text, because it kind of uses a shared space, and that's the benefit. Okay, so it's great to be able to query and then we use that as a means to test it both in these two different sort of spaces. Okay, a little bit quickly about the company. And finally, if you're a regular, you'll see I've managed to get this updated now to 400 plus customers. I've been meaning to do that for some time. But essentially, the company, SingleStore itself, started way back in 2011, okay, with product and company called MemSQL, focusing very much on OLTP and in-memory data processing. Subsequently added support for columnar support, OLAP. And then it didn't make sense to call yourself MemSQL anymore, so they rebranded to SingleStore. Took them a couple of years to do that. There you go. I mean, a space of about 5 years before they changed their name. But today it is a $100 million plus annual recurring revenue, ARR company, and over 400 global customers now. So that number has been 350 plus for a long time. I've been meaning to update that. So it's over 400 global customers. And along the bottom, you can see some of the investors, okay? So some of these companies actually use the technology, liked it so much that they decided to invest in the company and the product as well. So it's like that story of the gentleman who bought the shaver. He liked the shaver so much, he went and bought the company that made the shaver. So, it's kind of similar scenario. Okay, very briefly then, the second slide, just to show you the high-level overview. So this concept of managing both OLTP and OLAP, referred to as universal storage, okay? Single table type that can handle both types of data processing. Not many vendors out there can do that. For a long time, SingleStore was on its own. It was one of these things that you'd be really hard pressed to find anybody else doing something similar. A few are coming along, but keep in mind that we've been doing this for some time. Okay, it's mature, tried and tested technology. Lots of tools and technologies we integrate really well with, and some of these we'll cover in the near future. Okay, Euclide's got a plan for some webinars where we'll talk about, for example, integration with Kafka. We've covered Spark in the past. We'll do more of this in the future as well. And then if you've got data in external systems, say HDFS or Hadoop, then those are accessible as well. Okay, so this concept of pipelines, this is the animation here showing the ability to take data from these external sources, S3 bucket or Google or whatever, Google Cloud Storage, and being able to ingest that at scale into the SingleStore database environment. Okay, so we do work on the 3 major cloud providers, and today I will be very much using AWS. Okay, so there's a reason for that, because if you sign up for the free cloud trial, that is hosted on the AWS platform. We can run on-prem, and there's a Docker container as well. So one of the key sort of strengths of the product is this ability to manage multiple data types, this concept of multimodel. Okay, so relational, obviously, at its heart, geospatial, time series, we've covered these in the past. There are even customers using it for key value, interestingly enough. So JSON support we've done, and that JSON support has got better with the release of SingleStore Kai. Okay, so Kai is MongoDB compatibility. So MongoDB, one of the leading NoSQL database vendors out there, and we provide compatibility with that. And last but not least, vectors. Okay, so everybody's doing vector support today. The key thing to note here is that SingleStore has had vector support since 2017. And earlier this year, around about, I think, January, February timeframe, we released some updates to that. So there is a dedicated vector type, but you'll see some examples of that today, for example. And last week, for example, when we were working with the first version, first webinar talking about CLIP, we used LangChain, for example, to help us with that and to create the table. Today, we'll do it ourselves, okay? So there we go. All right, and then just to round it off, a variety of other integrations as well. So if, for example, you're interested in dashboards and building visualizations, we are going to use the built-in kind of Jupyter environment that is available in the portal. So if you are familiar with, say, Matplotlib, Plotly, Plotly Express, Plotly Go, Seaborn, any of those technologies and packages, you can easily create visualizations using Python. Equally, if you are using something like Tableau, for example, or Metabase, which is the tool that I like to use because there's a free version and you just need Java, you can be creating these pie charts, bar graphs, and so on, I mean, in minutes. So just provide the connection details where your data is hosted, server, password, credentials, and so on, okay? And you, as I said before, very, very easy to set up. And again, we've covered that in past webinars. Okay, very quickly then, some of the ways that you could utilize machine learning and AI with SingleStore. And again, this is not an exhaustive list, but just some examples. So we've demonstrated Spark in the past, okay, using mlib, for example. Today, we're going to be very much working with Python, but if you are familiar with Python and some of the libraries, scikit-learn, for example, is a great place to start, very useful. And equally, if you want to know the kind of, what vector functions we support out of the box, it's Euclidean distance and dot product. Cosine is not directly supported, but can be easily coded up in using SQL. And actually, within the documentation, it shows you how to do that. Okay, it's just a few lines of code that will easily implement that. One very nice feature, and I've used this in the recent past, and I've written about it as well in the more distant past, is this WebAssembly support that we have. So if there is some sort of functionality or some capability that you, some requirement that you have that the product doesn't support, you can try and code that up using WebAssembly. And one example that I demonstrated not so long ago, which is actually, I think, the last one of the last D-Zone articles that I published, was how to do sentiment analysis on Stack Overflow. Look at as you know, people post, they contribute. Sometimes they get rather angry. So sometimes they get frustrated with people posting. And so it's kind of nice to just analyze the data just to get a sense of, positive and negative sentiments. And that was using something called Veda, which is a library that's written in Rust, Valence-aware dictionary, and sentiment reasoner. And so that's very useful. So for example, if you have a requirement for some exotic way that you want to do similarity search and it's not supported by SingleStore and isn't, you can't use the SQL, for example, for cosine, then maybe you can just code that up in C, C++, or Rust, package that up, and then SingleStore will treat that as a UDF. Okay, it'll be able to execute that and run that. And that's run in its own environment. Okay, so in the event that there is some bug in your code, for example, it's not going to bring the entire system crashing down. So it's done in a separate space from the database engine. Okay, there we go. So very quickly then, so vector search, 2 slides on this. So this is the slide that I showed last time as well, the representation learning. So essentially, originally, I mean, if you think about ChatGPT, I mean, obviously OpenAI as a company has been around for some years and doing the research around this. But roughly 2 years ago, I mean, this became the thing that caught the world by storm. And since then, I mean, we have not looked back. But initially, it was very much focused around text. So think about this phrase: the quick brown fox jumps over the lazy dog. Okay, a well-known phrase in Western literature and the Western world. But equally, we may have an image of a fox jumping over a dog. We may have a video, for example, or sound. OpenAI, for example, provides Whisper, which again is something that I've used. It just takes my voice transcribes that and does a really good job, and it runs locally. I use that version. It's available on GitHub and freely available to use. And then we're able to utilize that as a way to use natural language, if you like, to query the database system. That can work really well. I mean, there's some cool demos that we've done around that. And then we need some mechanism, some standard way that we can represent these various forms of data. So, the text, the image, the sound, and so on. And vectors are the way that we do this, okay, through encodings, transformers, and so on. And I'm sure you're familiar with those if you use this extensively. And essentially, the black box, if you like, the technology that we're going to use today as well is CLIP, okay, to handle that for us, to generate those vectors for us, taking input both text and images, okay, in this case. And on Thursday, we'll look at video. So the video will have to be kind of broken down into individual frames. That's the solution that I've used. I mean, there may be other ways to do that as well. Okay, more details of that on Thursday. And then typically then we have some kind of query that we want to ask, and using these vector functions, Euclidean distance, dot product, cosine similarity, we're trying to find things that are similar or close, that are a good match, or a close match to something that we're trying to ask. We want to query the database system to be able to retrieve some data. And so this concept of nearest neighbors, which again, I'm sure many of you have seen in sort of RAG, semantic search. FaceNet is another great example of something that works with images. So you can do these searches and look for images that are similar to other images. I think the example that I've used is Emma Thompson, for example. And by the way, I'll give you a link, or I'll show you momentarily. There is a recommender workshop that we did not so long ago, where all of the notebook files, the data sets and everything are available online. And you're very welcome to download that and try that out as well in your own time. Okay. In case you're wondering who's using vector support, well, we have over 45 customers, and you can see some of the companies here: 6sense, Adobe, Goldman Sachs, LiveRamp, Siemens, and so on. Well-known names, household names, some of these around the world, who are actually utilizing vectors. And again, if this is something you're interested in and want to know more, just reach out to us, okay? We can send you white papers and give you further details of those. Okay, so let's move on then to recommender systems specifically. Well, many different ways that we could classify them. The most common types, perhaps, this kind of implicit ranking systems use actions like clicks or views to infer user preferences. So we go to some particular website, or, if you're on X, for example, you hit the like button, or you're on Facebook or something like that, you show a particular preference, whether you like something. And again, your choice of emoji as well can determine what you're trying to, show in terms of the sentiment for that. There are explicit rating systems as well. And by this, we mean we rely on direct user input, star ratings, reviews, for example. And again, you see those on e-commerce websites. People will star a particular product, maybe add some comments to that, and that can be helpful to other buyers as well. So I've done that a few times as well, on a well-known platform that I'm sure you can guess which one I'm referring to. And then lastly, content-based systems. So recommended items similar to those a user has liked before, using items like keywords or genres. So today, for example, we're going to be using, the concept of keywords very much for the text-based search that we're going to use. And for the genres, as I said before, we do have some content for the recommender workshop. We'll show you that momentarily. Again, you can try that out for that example. That's around movies, by the way. But again, many other types: collaborative filtering, hybrid recommender systems, knowledge-based recommender systems, context-aware recommender systems, lots and lots of possibilities and choices. So, this is a field that you potentially can develop many different solutions based upon the particular requirements. Okay, so let's drill down into the demo. Okay, we've got, let's just keep an eye on the time there. We are at 6:20, my time here in London. So first and foremost, let's get you set up. Okay, so if you'd like to follow along, please sign up. Okay, so you should have shared the URL in the chat, or if you saw that in the slide a little bit earlier on, it would be like so. Okay, singlestore.com/cloud-trial. Okay, very simple and straightforward. And if you do that, you will see this page. This is, I think, in dark mode, and you have a couple of options to sign up. You could use Google or Microsoft, or just do it the old-fashioned way: first name, last name, and email address, and just click continue. Okay, and there's a wizard there. So it takes like a minute or two now. So they ask you a few questions now just to make sure that in terms of determining your interests, and then you'll get an email and just verify that yes, it's really you and you are human. And once you do that, you can sign in. And once you sign in, you will get to the portal, which will look something like this. Okay, so this is just actually loading up the notebook that I'm using. But when you sign in, which will be portal.singlestore.com, here, let me just show you that. My magnifier will show you the first part there. Okay, so you just portal.singlestore.com. The page will look something like this. Okay, and by default, if you're doing this for the first time, what you will see is under deployments. Okay, again, if you have a look on the left-hand side here. Okay, let's click on that. You will see that automatically you have some compute resources created for you, and you have a database as well. Okay, so this is for the free shed tier. Okay, so there's nothing for you to create. There was a time when you had to actually provision these yourself, but now automatically, as you create a new account and you log in, it's there for you straight away. You can hit the ground running and start working with this. And this runs on the AWS platform, as you can see here. If you look closely, you'll see the logo at the top there. Okay, I'm just wondering if I could actually make this a little bit larger, zoom in. Okay, let's just see if we can get the text to be a bit bigger and zoom in a bit more. There we go. That should be a lot better there. All right. So the free shared tier has some limitations. You can see here, okay, 10 tables, 1 GB of compressed storage. And okay, you might say, well, that's not a huge amount. But the thing is, I think for very small scale, just as you're learning, just as you're getting started, dip your toe in the water kind of thing, it's great. I mean, I use it most of the time now. Only when I have some special requirements do I provision a standard tier. And you can do that too. So if you look at the top here, okay, if we take a look here, and you can see this kind of pull down. Let me just select this. So you can see one of the options here, it tells you already down here that the starter workspace under AWS is up and running, and you're allowed one of these, but you can deploy something yourself, okay? New deployment. And if we go and have a look there, you can see that the starter is ghosted out, okay, because it's already running. As I said, you're only allowed one of those, but you have the option to provision additional resources, standard, for example. And you can choose your group name here. Just take the default. You can choose your cloud provider. So again, you can see this is set to AWS currently. And then you have a lot more choice in terms of the region. So physically, for example, I might choose London, which is somewhat closer. There we go. And then you've got a few other options there. And then just next. Okay, let me just do this. And then here you have the option to choose how much CPU and how much RAM to configure. And by default, I think it's like $600 worth of credits that you're given. And so for this particular setup, which is the smallest currently, which is this S00, it's 2 virtual CPUs, 16 gigabytes of RAM. And in London, that will burn through 0.28 credits per hour. I think if it's in North America, it will be 0.25. Slight difference there. You can change this through the edit button here. Okay, so you can choose something bigger if you want. Okay, so here, for example, if we take a look at S2, that's 16 virtual CPUs, 128 gigabytes, and that will burn through 2.25 credits per hour. And estimated usage per month, assuming that you keep that running all the time, is 1,642.5 credits. Quite a lot there, but we'll leave that. Okay, so there we go. So if you need something more in terms of processing power, that's the way to do it. Okay, so let me just do this, and we'll go back. Okay, because we don't need that. The free shared tier is perfectly fine. All right. Now, hopefully, Yukti, you've shared the link to the repo today, the IPython notebook. If not, I think it's in Slack, so you should be able to pick that there. But let me just show the people that are attending today. So it's very simple. It's just github.com/veryfatboy, okay, all one word. And it should actually be the first repo that's on the list there. You can, let me just go here and just show you. Okay, so that will get you to my homepage there. And if I just select repositories, you'll see that the very first one here is this one. Okay, shopping Reco clip. And then if you click that, you see there is a notebook here. Okay, shopping _ Reco _ clip.ipython. And please, if you want to follow, I mean, you can do this later if you want. You don't have to download it. It's entirely up to you. But you can then grab it, either fork it or let me just see it. Trying to be too clever here. Just download it here. Okay, it's the option. All right. Now, I did promise that I would show you the recommender workshop as well. So that is here. Okay. So again, same place, github.com/veryfatboy. Okay, so that's recommender-workshop if you're interested. Okay, so this is like a movie, a Netflix clone, essentially. That's what you're trying to do. So you're trying to create, and this is fairly substantial. This is something that Yuki and I did a while back. It's a 2-hour workshop, and we actually done it at a conference as well in Germany a couple of months ago. So this has got like 6 notebooks, and there's data sets there as well. There's PDF versions of the notebooks. We actually have movie posters as well, and so on. It's actually quite cool to work through. So this is an alternative example as well, something to think about. All right. But let's go back here. And so once you've grabbed the IPython notebook, just go to the left-hand side here under Data Studio. Okay, that one. And if I click on this, you'll see here that under Browse, okay, that's what you need to do. If I select this, you have an option on the right-hand side here where this big purple button, it's got 2 options there. If you select it, either create a new notebook or import from file. And import from file is the one you want to choose. So literally, you can just drag the notebook to here where it says browse file, or use the file browser. Now, I've noticed something. Originally, it used to be, I think, personal used to be on the top and shared used to be underneath. They seem to have switched that. So not that it makes much difference. I mean, you need to give specific permissions and ability to people to access this. So don't worry if it, I mean, the fact that it's shared, it's simply shared within your organization, and your organization is the account that you have. So, if you've given other people access to that, if you added additional users, for example, and you shared that with them, they can access that. But it's nothing particularly to worry about, but it just seems to have switched it around. And that's all you need to do, okay? And then just click the button at the bottom, the import button. It's currently ghosted, okay, because there's nothing there, but that will load up the notebook for you. And this is the notebook, okay? So this is loaded. At the top here, I have that workspace and database selected here. It will be done for you automatically. If you've got like more than one of these, for example, you've got the shared tier plus, say, standard, or more than one standard, ensure that you select it correctly, okay? So here you can see that there's only one option, and by default, it will just pick that because there's nothing else running. So you do need this running in order to be able to execute the code cells. So it needs some resources to do that for you. All right. And the key thing here is that what we've simply done here is we've installed CLIP. There's several ways you could do this. I've opted to do it this way, just using pip. Okay, so that's github.com, OpenAI clip.git, and do it quietly. And of course, I need Torch as well here, okay? And then a couple of libraries down below here, clip itself, and a few other things. So we've got these image and display, okay, because we want to render some images too. And TQDM here, just because it's useful to show us the progress when we are working with some data and so on. Okay, and then the main thing here is to actually load clip and pre-process, okay? The two functions here, device. And then currently for this environment, I mean, it's going to be CPU. So you will find that some operations are a little bit slow. As I mentioned in the last webinar, they are gradually rolling out GPU support as well. So it's something that you might see in your account. If not, hopefully in the near future. So you have the opportunity to select a GPU as well, instead of just running on the default, which is the CPU. Okay, so that will download this, and that's 338 megabytes in size. All right. Now, this is at this URL here, as you can see, and this is a JSON file. And you are welcome to utilize this in your own efforts if you are building, say, an e-store, an e-commerce store, for example. Okay, so we'll look at the structure of this in just a moment. It's roughly 100 megabytes in size, and I can't remember off the top of my head how many records it contains, but I think it's in the millions. And we'll take a look at that. So here, what I've simply done is just read it in using this Pandas read JSON, which makes it very easy. And then if we take a look at the first sort of 5 rows here, you can see the structure of the data here. So it's got an ID column. There is a timestamp here created at. We have a title, okay? So a brief description of what the item is that we have. In this particular case, this first one is a logo print strap sandals. We have a link. Then in the next one is a URL to the actual image for that item. So it's not stored in here, obviously, but there is a hyperlink to where the image for this resides. The description is much more detailed beyond just the title. So there's a lot more information there about what this is. So in this particular case, you can see it says this product is a type of women's sandal feet. I'm guessing that's featuring or something. And then you can see it, because it's too long to show, it's just stopped there. We have price. Okay, there we go. The gender, whether it's male or female. Okay, in this case, it's for ladies. And then if I just scroll a little bit to the right here, oops, we can see here that we have a vector that's already created for us. Okay, this is for title. This is a vector that's been created based upon the title that we just saw a moment ago. And if we scroll a little bit further, even more to the right, we have another column that's a vector that's created from the description. And then we have a type ID at the end as well there. And so here you can see that we've calculated the vectors for you already based upon the title and based upon the description. And this is using OpenAI. So I think the length of these vectors is 1536. Again, I would need to verify that, but I believe that's the case. So no vectors for the image, but we do have vectors for the title and for the description. So again, if you want to experiment with this, test it out, maybe try it out with, on a small scale, building something like an e-store, you could do this. And we've already calculated those vectors for you. So particularly if you want to work with OpenAI, this will save you time and effort in doing this yourself. So it's, like I said, it's a 100 megabyte file. And I think there's tens of millions of these records in there. All right, so what we'll do is we'll just take a small sample of this, okay, just for the purposes of time. And again, I'm conscious of time, stay ahead of that. So we'll just take 10 records, okay, just to work with. Now you can scale this up as well. And then the first thing we'll do, because this clip is going to be used to generate the vectors for us, we'll drop the existing columns that we don't need for the title and the description. They serve no purpose for us in this particular case. And then again, if we take a look, once we've done that, you'll see that indeed we've lost those two columns here, but everything else is retained. Okay, so the timestamp, the title, the image, the URL to the image, the description, the price, gender, and so on. Okay. Here we've got a little bit of code. So what I'm going to do is taking the URL here, I am going to fetch the images for those, and then I'm going to use Clip to generate, use an encoder, generate a vector from that, and it needs a little bit of sort of careful treatment because, as you know, if you're doing things across the wire, across the internet, things tend to time out, okay, which is something that I found sometimes that, the download actually fails. It's a little bit slow, this process, hence the reason why I've kept it to 10 records, okay? There's a couple of gotchas I need to tell you about. That's one of them, okay? And so what this does is simply tries to grab the image there from the URL, and then we generate this kind of tensor, if you like, and then that's returned from that, and we get the embedding. And so this will try a couple of times. If it fails, it will do a back off. It will try 3 times, and then the time between each attempt is incremented as well slightly by sort of 2, 4, 6 seconds, just so that we give it a bit of breathing space to do that. So that is the thing that is a bit time consuming in this process. So if you're able to utilize local images yourself, or you have a source for images that you can get, possibly from this very same website that we have the URLs for, that's awesome. I think that will work a lot faster for you. And then another gotcha is that, okay, that's for handling the image, the URL, okay? And then what about the text? Well, one thing I discovered recently is that Clip has a limit in terms of the number of tokens that it can process if you're working with text, and that limit is 77. So here, what I've done is I've written a bit of code here just to limit it to 70. Okay, you can just see that, just to give it a little bit of breathing space as well. So not go right up to the absolute limit there, but then just tokenize this and then create the kind of text tensor as well in this case. And then finally here, what we're doing is we combine the two, generate the embedding, and we do it on a row by row basis for each row in the data frame. So all 10 records in this particular example. And so we've got the text vector, okay, the image vector, and then the combined, which is going to be a balance between both of them, equal sort of balance for both the text and the image. Okay, and we talked about this in the previous webinar. And that's it. And then here you can see we simply use TQDM just to give us a bit of sense of how long it's going to take to get this. So you can see here for those 10 records, it took over 2 minutes to process. That's terribly slow. I'm impatient, okay? If I'm working with, let's say, 100 or 1,000 or 10,000 records, it's going to take forever to do this. This is why I made the recommendation that if you can possibly grab those images and store them locally, I think the processing will be a lot faster. The text element, the text part of it is, we already have that part. We only have, for the images, we only have the URL. We've got to get the data, download it from somewhere, and it takes time. And here you can see that the code is kind of handled, at least in one of these cases, there was a failed attempt, but it was able to recover from that. And so it's done the 100% there. There's the website that we are trying to get this from. So it's a content development network, CDN-images, farfetch-contents.com. So that's where we're grabbing these images from. That's where those URLs go to for the images. Okay, so it's taken a bit of time to get that. Even it's only 10 records. Anyway, so once we've got that, we simply apply that as we've done here. Okay, so let me just show you that here. Okay, across all of the rows. in our data frame. And then if we take a look at the data frame, we can see that, yep, we've got all our original columns there, plus these 3 additional columns now that have been added for the text vector, okay, the image vector, and the combined vector, okay? So possibly you may not need the combined vector. I mean, you could calculate that dynamically. I just thought it was a bit more convenient to do that here. Simply makes it life easier when you're storing it in the database as well for database operations. Okay, so let's go down there. So have a look at this. Just on the off chance that we got NaN values, we drop any of those rows. I know in this particular case we didn't, but just there for safety. And then we find out how many dimensions do we have. Well, it's 512, which is the standard that CLIP uses. So, and then simply take the opportunity to create a table here where we're going to store that data into SingleStore. And here we use the dimensions value, okay, to create the vector column for image, for text, and for the combined. And then the rest are just standard types here. You can see like big int, for example, date time, and so on. Okay, it's standard types just to deal with all the other columns. So we are going to store everything in SingleStore. And then simply use the Pandas to SQL here to save all of that data into SingleStore. Okay. And a little sort of gotcha here using append here. Okay, so that it doesn't overwrite the definition that we've just used above here. Okay, and then we just take a random sample, 1 row at random from those that we've saved. And here we've got a little bit of code. Again, this is reused from last week. So get text query vector. Okay, so now we're going to ask a question. And we want to know, take the title of that random row that we've selected. Okay, compare it here against what we've stored in SingleStore using .product. Okay, that's the shorthand there for .product. And there's the value that we are passing in and give us a similarity score. So it's told us, and then just limit that to 3. Okay, so we found that this one, number 4, is the best match here for this. Okay, so, and we'll take a look at that in just a sec. Okay, and then similarly for the image, that same row, we do the same thing here. And again, code reused from last week as well. And we can see the actual image of the item itself. Okay, so we've got the text description and we've got the image being rendered here. And again, similar sort of operation here. We take the opportunity to ask and query against image vector this time. Okay, give us the similarity score. And it should come up with the same ID, 4. Okay, because it's the same item. All right. And indeed, that is the case. Okay, we've got a similarity score of 1. Perfect match. All right. And then here for the combined query, we could take both of those values and similar to the way that we stored these, again, using the combined vector column here and the combined query vector just above. And lo and behold, we get number 4 as the best match here. Okay. There we go. All right. Now, taking this a step further, then, how could we incorporate these ideas if we want to build some kind of recommender system? Here, what I've done is taken something then that I've just thought up, a couple of words that would make sense. So I'm interested, for example, in a pink shoulder bag. Okay. All right. And I'm just curious to see what sort of results I would get back from here. And I'm, again, using the combined vector here. Okay, so search both the text and the image space and return the result. Okay, so it's stored in here. Okay, this is one of the mechanisms that we can use. Save it in this variable. Okay, so this is a SQL cell, for example. Okay. Convert that result to a data frame, just make it a little bit easier to work with. And if we take a look at the result, it shows us, and what I've done here is I've returned the ID, the actual image, okay, which gives us the URL, as you can see, and the similarity score. Okay, so for that particular query, it's returned an ID of 6. And if we render the image there, you can see indeed it is a pink shoulder bag. All right, so here it should be relatively simple to build a nice front end. And as I mentioned last time, just use Vercel, Streamlit, provide a text box where you can enter the actual search pattern that you're looking for. Okay, whatever it is that the particular item that you're interested in, whether it's blue denim jeans, size whatever, medium, extra large. In this case, we were looking for a pink shoulder bag, for example. Equally, you could provide a means to upload an image. So if the user has a particular image in mind and they're looking for something similar, you could provide a means to be able to upload that image. We get the embedding, we get the tensor and the vector from that, and that could be used as well as part of our query. So not just text is not what we're limited to, but we can equally match the image or the combination of both of them, as we've just done in this particular case. So that will give us the ability to search. We can get recommendations. I've just opted in for simplicity and speed just to keep it down to this, but equally we could iterate over these other values. So here we've just limited it to 3. Okay, and there's nothing to stop you from rendering all 3 of these if you wish. But again, bear in mind that doing so from this website is slow. I fear that if many of you are trying to do it right now, you may be getting rather frustrated because of the slow, the latency and the network. If there's about 30 or 40 or 50 people hitting that website right now, and there is, no randomization, randomization only in terms of 10 values. You're picking one from those 10 that we've retrieved. That is going to be very slow. Other than that, what I've noticed that yes, there is a small limitation in terms of Clip's ability to handle the number of tokens. Its limit is 77, but that's quite generous. I've opted just to use the title, and that is my text search, but I could equally use the description, which is more detailed. There's a lot more keywords that probably exist in that. But bearing in mind that I would need to be wary of the fact that there is a limit that I could, how many of the I could pick from the text description. So key things here. This works well. I'm pleased with the results. It is able to query. I have the flexibility of choosing how I want to ask the questions, whether I want to use it limited to just text, whether I want to limit it to just images, or a combination of both. That gives me a lot of room for maneuver, and I could choose whatever is the best approach for me. The downside, as I said before, is the latency, the time, and the cost that seems to be incurred in terms of just grabbing those images from this external website. If I had the opportunity, I would probably download those locally and then process them locally, and I'm sure that would be much, much faster to do. Other than that, being able to store the data into SingleStore and the query, if you look at the timings for these, I mean, you'll see, for example, here, some of these queries are just incredibly fast. I mean, 10 milliseconds, for example, for this, and 82 milliseconds here, for example, for this particular SQL query. So that is not the bottleneck. The database can handle all of this. It's just the ability to get the stuff in and access it from these external sites that seems to be the problem here. But there is nothing to limit you once you've got that in, and you can store the details of the images, that you can store the descriptions, the titles, and so on, and you can search across them using these vector embeddings, and the results seem to be very good. And again, more research and exploration there recommended, as I did with the last webinar. Okay, again, let's stay on top of time. Okay, so key summary. Well, again, bear in mind that SingleStore vector support has been there since 2017. The dedicated vector type we've just touched it very briefly last time and this time. I mean, there's so much more around that in terms of choosing, for example, indexing, various strategies that you can use, the types of indexes as well, which are going to work really well at scale. That's the key thing. But you saw that there are over 45 customers that we have this has been in the product since 2017. It's mature, tried and tested, used in production environments, and people are actually using this in, these are mission critical systems that they are building. Clip, I like it a lot. I think it's very flexible. The fact that it's free to use is awesome. The downside, you saw a couple of gotchas there, some limitations around that. If you can overcome those and find sort of ways around those, I think this will work really well. It's a great way to build. In this particular case, you saw, the makings of a kind of an electronic store, e-store, where you can search for items. You can build a nice front end to this. Users can query. They can look for things that match, even upload their own images, for example, and say, well, look, I've got something like this. What can you show me that looks similar to this, for example, in terms of an image? That could be an awesome way to be able to provide the user with the ability to search the store that you have. All right, then. And in case you're interested, we have this Go Live acceleration program where my colleagues from the SE team can assist you. If this is something that you're interested in, they can work with you. We can do these POCs, workshops. They can do an assessment, design and plan, migrate and validate, post-migration support, cutover support. So we handhold you through the process, and we work very closely with you to ensure that SingleStore is the right solution for you. And if it is, and you've decided that it is, then we work closely with you to ensure that you are successful, and we are successful in helping you. The customary, we are hiring, singlestorecareer.com/careers/jobs. So please check that out if this is something that interests you and you might be interested in working for us. And my favorite quote, as I always use, any sufficiently advanced technology is indistinguishable from magic, okay, from Arthur C. Clarke. So great way, I think, to utilize Clip. It works well. Some caveats there, some limitations that you can see, but that's not really around the technology. It's simply getting that data and downloading it. And I think that's the bottleneck, and that's the delay, if you like, the latencies there in terms of being able to retrieve the actual images. Great if you can get those and use them locally. I think this will be much, much faster in terms of getting that initial sort of minimum product up and running, and then you can embellish it and enhance it as you wish. Okay, so no problems in terms of building a nice front end around that. And with that, we have time for questions. So Euclid, I finished a little bit earlier today, so I will leave you to pick some
All right,
questions.
so thanks everyone for sticking till the end. And we have certain questions for you, Akmal. So if you
Yeah.
feel like picking out any questions, just feel free to do it. Or if you want, I can also pick out something.
Okay. All right. Let's just have a look then. So let's take a look. See if I can get some. Okay. Yes. Deborah asked, will the recording be shared? It will indeed. Okay. So you should receive a follow-up. How to get the last week's recording on Clip. Okay. So what you need to do is if you go to the events page where the webinars are posted. For last week's one, you'll see it as an event that's passed. But what you can do is if you want to view it, just put your details in. I think there's a simple registration process, literally, and then you get access to the recording, which you can view in your own time. Francis, hello, well from Frank, Canada. Yep, thank you, Frank. It's great. And I missed the last two presentations for the SingleStore. Could someone reach out to follow up? Because yes. Francis, please drop us an email at team@singlestore.com. Okay, make yourself prominent. Tell us exactly what the problem is, what the issue is. Okay, and we'll get someone to connect with you and follow up. Devesh says, request you to explain the complete pipeline so that we can get a broader view and then we can easily understand the code. Yeah, so the process is simply this. We just grab the data. Okay, there is a data set available from the SingleStore website, which contains approximately 100 megabytes of product data in JSON format. And all I simply did was using the Pandas, the JSON mechanism of reading a URL, simply loaded it into my environment. And then I simplified it just for the purposes of today, simply because it's a bit difficult to go through it. Pick first 10 records that are available. And then what we did, we used an encoder clip, okay, to take the image. Okay, and the image is available through the URL that's in the dataset. So we have to follow that URL, download the image locally, encode it, okay, create the vector. And then for the text, it's a lot simpler because the fields are already there. And in this particular case, I chose the title simply because it's shorter. And that's it. So once I've got these two representations, I simply add them to the data frame. And then what I've also done is combine the two, give an equal weight to them, and this is what the combined column is. So this is great because in Clip, the text and the image share the same space. Okay, that's the key thing. And this is why this is so awesome and works really well. And then other than that, we just store it in the database, and then we can use SQL to query it. And all we are doing is using dot product, and you saw the shorthand for that. And so literally, in order to do the query, though, we need to pick something out, either an image or a text string that and you saw in the last case there, I was looking for pink, shoulder bags. And we have to encode that into a vector representation so that we can then do the dot product. And again, you can see that in the SQL code. So that's very straightforward. That's essentially it. So there's just step by step, take the data, generate the encodings, both for the image and the text, and do the combined one as well, store it in the database system. And then in order to query it, we obviously need an image or a text to be able to do that again, okay, so that we can do the match and the similarity search against the vectors that we've stored in the database. So those aspects of it are all straightforward and all simple. The delay and the latency and the bottleneck is the problem of grabbing those images from this content development network. That was the time-consuming part. And sometimes it fails. So the code is designed to handle at least up to 3 failures. Okay, once it fails a third time, it gives up and then moves on to the next one. So there is a bit of flexibility there. You saw that in the notebook. I think the notebook that I used, I shared with you, you actually see that there was an error there with one of those the first time it tried to download it. But if there is a way that you can access images, or you have the opportunity to download more of those images from that website and store them locally, rather than using the URL, simply point them to the local location that you've got them. And you can do that within the portal, for example. Just create a directory within the environment, download them to that directory, and then just access them from there. That could be a lot easier. Once you've got all the data in the database, makes life easier. You could, in theory, I suppose, even store the image itself. I haven't gone that far, but I have done it with grayscale images. I mean, directly in SingleStore, and then we retrieve that. And that way, you're not relying upon any external sources. Therefore, you literally have the image itself stored in the database system as well, although that will grow the size somewhat, depending on what the representation of the image is. Okay, there we go. Nera's asking, will the recording be shared? Yes, it will. Vector embedding, is it open source? It is, yes. All of this is open source. I did not use any commercial source to generate the image. Everything was done by Clip. Yeah, all done by Clip. Okay. What will be the next steps in employing such a Reco system to a real e-commerce site? That's a great question, Demon. So the key thing here is you saw it on a small scale. It seemed to work reasonably well. Take the opportunity to add more data. That's what I would say. Stress test it. The challenge here is getting those images. If you can get yourself like 1,000, 10,000, 100,000, that's a bit extreme. But depending on what sort of e-commerce site you're building, you may not have that many products, but at least I think up to sort of 500 to 1,000 different products might be a good way to stress test it. Being able to query that should be much, much easier. Should be no latency, no delay. The next thing I would recommend is just building a nice GUI front end in front of that. So here you saw the raw code, if you like, the SQL and the process of generating embeddings. In the real e-commerce site, you wouldn't need those. Okay, the code itself would be hidden. So if you build like a nice Streamlit front end, what you could do is you could have like a text box where the user enters in the search pattern that they're looking for. And then you could select have 3 radio buttons to say, do you want to search the text, do you want to search the image, or you want to combine? That might be something you could offer them. And then also have the ability for the user to upload an image themselves, which you could then encode and then compare as well. So that could be a really useful feature. Not too many websites that I know of offer that capability, but that might be very nice because the user may have for a particular piece of clothing, for example, or a particular pair of shoes or a bag or something that they really like, and therefore looking for something else that might be quite similar to that. And then you give them the opportunity to upload that and compare that to what's already exists in the database system. So scalability as far as SingleStore is concerned, no problem. Clip seems to work well. Like I said, the couple of gotchas that I pointed out to you, those would be the limiting factors, I think. Other than that, I don't see a problem. And if you want to see a fully functioning website, we do actually have a demo, which again, I'll give you the URL, which she will share in the follow-up email with you, where you can go and actually see something that is not just 100 megabytes of data, but it's much, much larger. We actually use this as a demo at many of the conferences. When we have booths at conferences, we run this e-store, and that was built by my colleagues, Yaroslav, and that's awesome, okay, because it's very similar, but it doesn't do the image matching. It just allows you to search on title and description. Okay, so that's the vectors that you saw in the original data set that I was using there. Raymond, thank you for your comments, sir. Jack, I'm curious, can a vector database be just a relational? Yes, absolutely. So thank you for your question. So your question is, can a vector database be just a relational database? So in the case of SingleStore, because it's multimodel, a vector is just one representation, one mechanism, one means, one data type that we can store. At its heart, it's still relational. You saw very much the creation of the tables. You saw the SQL queries. Would pure vector databases be able to replicate this? I don't know. I think pure vector databases are designed for handling vectors. Simple, and that's the only problem they go after. Generally speaking, and my experience having worked with many other technologies in the past, is that with something like SingleStore, vector is one type. You may require it, you may not require it. You may, for example, want some geospatial, you may want some time series. Those are built into the product. You don't necessarily have to use them if you don't want them, but they are there. Those capabilities and those features are there. At its heart, it's still relational. So you can use SingleStore as a pure relational database with nothing else, and that's absolutely fine. I mean, you think of it as a general purpose database engine, okay? A bit like a Swiss Army knife, okay? It can do many things, but you don't have to use everything. Would a vector database be able to do relational? Hard to say. I think that's the question you're kind of asking. Not something I really thought about, but I think it would be a challenge for them. Relational as a technology has been around for a long time. Cost-based optimizers are things that people have researched to death. They're very, very efficient at what they do. So very difficult to answer. Yes, AJ, you're asking what's the link to the GitHub Reco? Recommend us something? Yeah, very easy. So it's this one here. Let me just show you this, okay? And then we'll just wrap up in a couple of minutes. So I'll show you this. It's just github.com. Again, very fat boy. There's a long story around that. I may tell you the story in more detail one time. And then it's just recommender-workshop, as you can see there, right? So there's 6 notebooks there. The first 4 were part of the workshop we ran. The last 2 were optional using Spark and I think something else we were doing. But essentially, we work through the process. And again, it doesn't require any money from you. You don't have to, no commercial LLM or anything used. Everything is done within the environment. It's all free. And so we take movies and we build a kind of a Netflix clone, if you like, and that's what we're trying to achieve there. Okay, so hopefully that will help you. Ranga, thank you for your comments, sir. Peter, how would the query performance change if we had used all the data instead of just 10? Yeah, Peter, I think the query itself, as far as SingleStore is concerned, and that's a great question, I don't think there would be an issue. Okay, but the vector search part is simple and straightforward. It's just getting that initial data in, and as I said, the key problem was just the download from the content development network. It's slow and it times out. So the image, that's why I limited it to 10, simply because, you know, and again, if you try it for yourself, you may well hit those problems as well. But the database system has no issues with dealing with that. Like I said, we have customers deploying vectors in production environments at scale, and they are storing hundreds of millions of vectors. You know, these are, and again, if you're interested, we can give you case studies and give you customer references if this is something you would like. Okay, great. Awesome. Thank you very much, everyone. And let's finish off there. We always overrun. So, Yukti, I'll hand back to you. So, Yukti, I will send you the link to this recommender workshop as well as the clip. And I think some people were asking about the last webinar we did, which was it Thursday last week, I think, or Friday? I think, I can't remember. I think it was Friday, wasn't it? Friday evening. And we can include those in the follow-up email, which everyone who has signed up should receive. And if you're interested, please join me again this week on Thursday, where we'll do the last part. We're going to look at videos, okay? And the notebook for the videos is something that I spent quite a bit of time. So there's a lot of text, TLDRs, as well as summaries describing that in much, much more detail. So it's a bit more like a book. So you can read through that and you'll understand the code much better. These ones, because we're not quite going into so much depth, hopefully it's fairly straightforward and easy to understand what's going on. There's comments interspersed with it, but essentially we tried to cover it, the main aspects of that in the webinar itself. So we can do that for you. Okay, and with that, let me hand over to Yukti for wrapping up here.
All right. Thank you so much, Akmal. I feel like I have an issue with my camera right now. It's all right. So, yeah, everyone, thanks for attending. And I will send up the follow-up emails ASAP, and whatever resources Akmal had mentioned, you will get them all. And yes, you can find the recordings on our events page. And if this topic was interesting to you, feel free to head over to our resources page and you can find the webinar section, and you can, obviously register to the upcoming webinars. And I hope to see you all there, and thanks everyone for joining. Have a great rest of the day, and thank you so much, Akmal, for the amazing presentation. Really appreciate it. All right,
Thank you.
bye.